Okay, so last lesson we talked about rotation. So let's go over the things that we did. We did rotations, translations, we did reflections, and so now the last part is dilations, contractions. So a dilation, so we talked about things that are like this. We talked about zooming on a tablet or smartphone. So I'm just going to put zooming here. Zooming in or out. And then on a screen. So characteristics, does the shape change? No. So shape stays the same, but what's different?
The size.
Size is different. Are the angles the same? Yeah, in order to stay, so the angles, I'm going to put angles the same, stay the same. And then things I've already learned for this unit, I can use for this, is we know about scale factor. Do you guys remember learning about scale factor?
Yeah.
Like timesing everything by the same number. So then here's this example. So this is a picture, and she wants to put it on a blog, and right now it's big, but she needs to shrink it down, and she's going to do some fancy math instead of just like moving it. So she wants to make it so it's 120 by 60. So basically she wants to know, what is she going to have to shrink this 480 by? Like, what would she have to times 480 by? In other words, we want to do 480 times by what equals 120. So what do we have to do to 480 to get it down to 120? Divide by 4, which is the same thing as timesing by 1/4. Nice work. So the scale factor would be 1/4. So I always take so when I do this, I do the original, or I'll do the new divided by the original. And that will equal the scale factor. Did you guys write this down? New divided by original equals scale factor? Because if you did, you are doing exactly what you should be doing. If you have not done it yet, do so now. New divided by original equals the scale factor. That's kind of sloppy handwriting, I'm sorry. Maybe I'll do scale and I'll make factor nicer. There, it's a little bit nicer. Okay. Then, so we have dilations on the coordinate plane. So dilations will have a scale factor, k, so they can make them go bigger or they can make them go smaller, and even if k is 1, if the scale factor is 1, it's the exact same thing. But the nice thing is when it's dilated around the origin, all you have to do is multiply the x and the y by the scale factor. So right here, we're going to go like this and put a box around this, and we're going to put helpful by it again. Helpful. So all you have to do is multiply the x and the y just by the same, whatever the scale factor is. So if we had a point that was 1, 2, and we knew that our k was equal to 3, then my new one is going to be, what is 1 times 3? 3. And what is 2 times 3? 6. And that's all you would do. Like, that is it. Pretty easy. Would you guys agree?
Yeah.
Okay, good. So let's try this. So a triangle has these vertices. Find the coordinates of a triangle after a dilation with a scale factor of 4. So they took all the points and times them all by 4. This is their work. And then they just got that. And that's it. That's all you have to do. Pretty easy, yeah?
Yeah.
Because it tells us all the information. So here's our new one. This is what you're going to try out on your own. Figure has those vertices, and we want to figure it out after a scale factor of 2. So what does that mean we're going to do to all the x's and y's in these points? Times them by 2. Ready? Mark, set, go. W prime, oops, that said lots of thing W. Okay, W prime X prime Y prime and Z prime. Okay, figure them out now. So we're timesing by what again? 2. So what is W prime?
Negative 4, 8.
-4, 8. Good. What is X prime?
2, 8.
2, 8. What is Y prime?
It is negative 6, negative
2. Pretty easy, huh? Z prime is
6,
negative 2. Good. That's all you have to do. That's it. You're done. Easy? Okay. Then it's the same type of thing when we have different points like this and the scale factor is 1/2. You just half everything. Notice that they used fractions. You can also use a decimal. It doesn't matter which. Fractions are sometimes easier. But that would be taking big and then you're shrinking it down to make it small. So the origin is that point that you're going bigger or smaller from. Does that make sense? You know how we talked about with the screen, you can put it there and then like make it bigger or smaller. This is our original one, the blue, and after we shrunk it, it went down to the green. So then, yep, this is the same type of thing. It's just that here's the image, and then when you do a scale factor of 3, you're just going to times all those by 3 and then graph them. So start by writing down the points, the original points. If you don't want to write down the original points, I guess you don't have to, but you do have to write down the one after the translation, or after the dilation. So I like to write them down. So the scale factor is 3, so what is F prime? Scale factor is 3. Negative 3, 3. G prime? 3, 3. H prime?
6, negative 3.
6, negative 3. And I prime?
3, negative 3.
Negative 3, negative 3. And then you have to graph.
So this is me graphing all of them, and I have to label all the points. Might be the hardest part for some people. So F is back 1, up 1, dot F. G is 1, 1. G. H is 2, negative 1. And I is negative 1, negative 1. What kind of shape does that look like? Trapezoid is an okay description. I like it. It's a good one. Okay. And then we graph all the primes.
Whoa.
Whoa, do you need me to wait?
Why is it so small?
Because that was our original one. That's just the points that they gave us.
Oh.
And now we're going to graph the new one, scale factor 3. Oh, you're like, what did I do wrong? Yeah, so then we go back 3, up 3. Here's our F prime. You need to graph both. So if you haven't done both, then you need to do it. Over 3, up 3. And then 6, negative 3 is H prime. And negative 3 is I prime. So it's like you took your fingers and just zoomed in on it.
It looks like a tunnel now.
It looks like a tunnel. Yeah, I agree.
So we circled the part on this page, like we did this part, the new divided by original equals scale factor. Will you guys put a box around that and then put the word helpful by it? If you didn't write it down, write it down. New divided by original equals the scale factor. I hope that you wrote that down because you were supposed to, but you're going to put a box around that and the word helpful. This is where it comes in handy, is on number 3. If you want to rewrite that, that might be a smart thing to do. So new, which they call the new one, they call it the image. New or image, divided by the original. Equals the scale factor. Okay. So through a microscope, the image of a grain of sand with this big of millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? So which one's the new one? Is it the 11 or is it the 0.25?
11.
It's the 11th thing. So we take because that's the new one, because that's what you see through a microscope. Maybe you could also put the real one by it also. The real thing is small. So, oh no, sorry. The original one is the real, I meant to say. So we take our new one, which is 11.25 divided by 0.25, and then you get 45, and that's the scale factor, and that's all you do. Pretty easy. Would you guys agree? Okay. So last one. So Lucas wants to enlarge his 3 by 5 inch photo to a 7.5 by 12 inch. What is the scale factor? Which one's the new one? So I'm gonna say, so it's gonna be 7. I'm gonna say 7.5 for 7.5. Is that okay for you, with you guys? And then we're gonna divide it by the original one. How big was the original one for that?
3.
It was the 3 because it was 3 by 5. So 7.5 divided by 3. Calculator people, what is that?
Wait, wouldn't it be 3.5? Because it's
No, it says 3 by 5. So it's 2.5 is the scale factor. And that's it. You might have to change that into a fraction on Alex, but it's the same idea. Okay, so if you are doing Alex, it's just in Alex. If you are doing the book, then the problems are 1 through 6, 9, and 14 through 21.